Hello everyone, today I'll be teaching you how to analyze displacement time graphs, velocity time graphs, and acceleration time graphs. Now, your teacher might have taught you to memorize what the slope and areas mean, and while these are important things to know, I'm going to be teaching you why these things are because I think it's a lot easier to understand why these things are rather than just memorizing the slope and area meaning. Now let's get to it. So first, we're going to be going over a displacement time graph. Now, the main thing you want to know about a displacement time graph is the slope equals the velocity. This is probably what your teacher taught you to memorize, but I'm going to show you why this is. Now, let's recall in math that slope is just the rise, which is this right here, divided by the run, which is this right here. Now, let's actually look at our displacement time graph. What is our rise? Well, our rise is this right here, our displacement. So this would be S divided by our run, which is time, which is t. Now, does this look like a familiar formula to you? Yes, it does. This looks like the velocity formula. So this is why the slope of a displacement time graph is velocity. So if this was, let's say, a car, and this is its displacement time graph, and we were to search for its velocity, well, its velocity would just be the slope. So v would be 100 meters divided by 10 seconds. And this is just 10 meters per second. So this car right here would be moving at constant velocity at 10 meters per second. All right, so in our previous example, we had a car moving at constant velocity, so we had a straight line. But here we have an example where there's a curved line instead, which means that the car is no longer moving at constant velocity. So here we have to differentiate between two variables, which is the instantaneous and average velocity. The instantaneous velocity refers to velocity at a certain instant in time, while the average velocity looks more into its whole journey at a course. So let's say I wanted to know the instantaneous velocity at 5 seconds. So it would be this point right here. Well, in order to find the instantaneous velocity, we can no longer just look at the whole line because, well, it's curved. Instead, we would draw a tangent line, which just barely scrapes over that point, and this would be the instantaneous velocity at 5 seconds. And let's say we wanted it at, I don't know, another point in time here. So we draw another tangent line here to find the time, and we calculate the slope of the tangent line that we just drew. So note, for instantaneous velocity, we always want to find the tangent line at that point. And in these kind of questions, you really just have to estimate and eyeball it. Usually in the IB exams, there's a certain increment that you have to meet. So, for example, the answer could be between 4 or 5.5 meters per second squared. Usually the examiners are very generous with this. As long as you're close within that range, then you're good. But what about the average velocity? In the average velocity, you look at more of your whole journey. So the formula for this would be total distance divided by total time. And this is quite easy. In this case, we just say, all right, if I began here and this is my end point, let me just erase the tangent line because it's sort of in the way, then I just draw a line through the beginning and end point. Or I could just say, okay, well, the total distance I traveled, so V average. The total distance I traveled was 100 meters in 10 seconds. So this is once again 10 meters per second, but this is the average velocity. This is the car's average velocity over the time, but it doesn't necessarily mean that it's at 10 meters per second the whole time. As I stated, there's the instantaneous velocity, so it could have been, I don't know, moving at 1 meter per second or 20 meters per second at a certain instant in time, but its average is 10 meters per second. All right, now we're going to be moving on to velocity time graphs. Again, I've shown you the important components you need to know about a velocity time graph. The slope is the acceleration, and the area under the graph is the change in displacement. Again, I'm going to show you why this is. Remember, slope is rise over run. All right, if our rise is change in velocity and the run is time, again, this is the formula for acceleration. But what about area? So if we wanted to look at the area of this, it would just be this and this, right? So we'd multiply those two variables. That would be velocity multiplied by time. But as we've seen before, velocity really is just the change in displacement, or displacement over time. So that means if we just did some basic algebra, change in displacement is velocity multiplied by time. So the area has to be the change in displacement. So in this case, if I was asking for the acceleration of this theoretical moving object, let's say it's a car again, acceleration would be its slope. So it's 5 meters per second divided by 10 seconds, which would give me 0.5 meters per second squared. And if I wanted to find its change in displacement, I would find the area of this under the graph. So this would be 1.5, 5 multiplied by 10, which gives me 25 meters. Again, I want you to know why it is that we calculate the area under the graph and the slope for these variables instead of just memorizing this. While memorizing is helpful in the beginning, it's a lot easier to remember these things when you actually understand why it is. All right, now I'm going to show you a question that you're likely going to see on a test paper, which is using what we talked about earlier. So in this case, we have another theoretical moving object. They're asking what is the displacement, and we're assuming positive values are moving to the right and negative is to the left. So I'm going to write this here just so we always have that in mind. So what did we just say about velocity time graphs if we wanted to find the change in displacement? That is the area under the graph, because as we know, velocity is change in displacement over time. If we did algebra, that'd just be velocity multiplied by time for the change in displacement. So we want the area under the graph. But as you can see, our graph is kind of weird. It goes positive here and then negative here. So what would be the area under the graph? Well, for here, in the positive side, it'd be easy. It'd just be this. But for the negative side, it can be kind of hard to tell. So just note that for the area under the graph, it's always from the under the line, the slope, and the x-axis. So it'd be here. Now, it might be tempting to treat both of these as positive areas and add them together, but one thing to note is that because displacement and velocity are both vectors, we do have to consider the fact that this is actually a negative area, and this is a positive area. And why do we need to note that? It's because we stated that negative is to the left and positive is to the right. In this positive area right here, this object was moving to the right, but when it was moving into its negative area, it means it was moving to the left. So from 0 to 40 seconds, it was moving to the right, and then it started moving to the left from 40 to 90 seconds. All right, so now let's do the calculations. So essentially, we have to find the area of this one, which let's call A1, and area of this, which is A2. So it'd just be area 1 plus area 2. But because we know that area 2 is a negative value, let's just call that minus 2. All right, now let's calculate this. So this is a triangle, so this would just be 1/2. This gives a negative displacement of 100 meters. And this just shows that overall the displacement of this object is 100 meters to the left. All right, now the final thing we're going to be looking at is acceleration time graphs. And the only thing you need to know is the area under the graph is the change in velocity. Again, this is better shown. So area would be acceleration multiplied by time. And as we know, acceleration is just the change in velocity over time. So change in velocity is area multiplied by time, hence area under the graph. All right, in summary, in displacement time graphs, the slope is the velocity, the tangent line at a certain point is instantaneous velocity. In a velocity time graph, the slope is its acceleration, and the area under graph is the change in displacement. For acceleration time graphs, the area under the graph is a change in velocity. An important thing to note is because these are all vector values, you do have to keep in mind the negative and positive values in your calculations. Thank you for watching this video. I hope you found this helpful, and good luck with your studies.